Hello, and welcome to Relaxing Facts. I'm Chad K, and today I will be talking about the Andromeda Galaxy. Each week, I share interesting stories and little-known facts on a variety of topics, accompanied by gentle, soothing music. My goal is to help you find a sense of calm during your busy day. Feel free to settle into a cozy spot and let yourself be carried away by these relaxing facts. The Andromeda Galaxy is the nearest large galaxy to our own Milky Way, and, after the Milky Way, it is the most important galaxy for understanding how spiral galaxies form, grow, and evolve. Known to astronomers as Messier 31, or simply M31, Andromeda has fascinated observers for centuries, long before anyone knew what a galaxy actually was. On a clear, dark night, Andromeda can be seen with the naked eye as a faint, elongated smudge in the constellation Andromeda. This makes it the most distant object visible without a telescope, lying about 2.5 million light-years from Earth. When you look at Andromeda, you are seeing light that left those stars long before humans existed, traveling across intergalactic space to reach your eyes. Ancient astronomers noticed Andromeda thousands of years ago. Persian astronomer Al-Sufi described it in the year 964 as a small cloud in his Book of Fixed Stars. For centuries, that description did not change much. Through early telescopes, Andromeda appeared as a fuzzy patch of light, often called a nebula, a Latin word meaning cloud. No one knew whether it was part of our own galaxy or something far beyond it. That question remained unresolved until the early 20th century. At the time, astronomers debated whether spiral nebulae like Andromeda were small objects inside the Milky Way or enormous star systems of their own. This debate came to a head in 1920 during what became known as the Great Debate between astronomers Harlow Shapley and Heber Curtis. The answer came just a few years later, thanks to Edwin Hubble. Using the Hooker telescope at Mount Wilson Observatory, Hubble identified a type of variable star called the Cepheid variable inside Andromeda. Cepheid variables pulse in brightness in a predictable way, allowing astronomers to determine their true luminosity and therefore their distance. Hubble's measurements showed that Andromeda was far too distant to be part of the Milky Way. It was a galaxy in its own right, containing hundreds of billions of stars. This discovery fundamentally changed our understanding of the universe, revealing that the cosmos was filled with galaxies far beyond our own. Today, astronomers estimate that Andromeda contains roughly 1 trillion stars, possibly more than twice the number in the Milky Way. It is a spiral galaxy, similar in shape to our own, with a bright central bulge, sweeping spiral arms, and a vast disk of stars, gas, and dust. Andromeda spans about 220,000 light-years from end to end, making it significantly larger than the Milky Way, which is about 100,000 light-years across. At its core lies a supermassive black hole, estimated to be about 100 million times the mass of the Sun. This black hole is relatively quiet compared to those in some active galaxies, but it still exerts a powerful gravitational influence on the stars near the center. Surrounding the core is a dense bulge of older stars, many of them red and evolved, indicating that the central region of Andromeda formed early in the galaxy's history. The spiral arms of Andromeda are rich with gas and dust, the raw materials for star formation. Within these arms are clusters of young, hot, blue stars that burn brightly but live short lives. These regions also contain glowing nebulae, clouds of ionized gas lit up by nearby stars. Compared to the Milky Way, Andromeda appears to be forming stars at a somewhat slower rate today, suggesting it may be entering a quieter phase of its life. One of Andromeda's most interesting features is its system of satellite galaxies. Dozens of smaller galaxies orbit Andromeda, bound by gravity. Some are dwarf elliptical galaxies, faint and lacking much gas, while others are dwarf irregular galaxies with ongoing star formation. These satellites provide important clues about how large galaxies grow by absorbing smaller ones over time. In fact, Andromeda bears clear evidence of past galactic collisions. Astronomers have discovered streams of stars arcing through its halo, the vast spherical region surrounding the main disk. These stellar streams are the remnants of smaller galaxies that were torn apart and absorbed by Andromeda long ago. By studying these streams, scientists can reconstruct Andromeda's merger history and better understand how galaxies assembled themselves over billions of years. Andromeda's halo itself is enormous, extending hundreds of thousands of light years into space. It contains not only stars, but also large amounts of dark matter, the mysterious substance that does not emit light, but makes up most of a galaxy's mass. Dark matter plays a crucial role in holding Andromeda together and shaping its rotation. Observations of how fast Andromeda's stars move reveal that visible matter alone cannot account for the galaxy's gravity. Without dark matter, Andromeda would fly apart. One of the most fascinating aspects of Andromeda is its relationship with the Milky Way. The two galaxies are part of a small collection known as the Local Group, which also includes the Triangulum Galaxy and dozens of smaller galaxies. Andromeda and the Milky Way are the two dominant members of this group, locked in a slow gravitational dance. Measurements show that Andromeda is moving toward the Milky Way at a speed of about 110 kilometers per second. This means that in roughly 4 to 5 billion years, the two galaxies will collide. While the word collision sounds violent, individual stars are so far apart that direct stellar impacts are extremely unlikely. Instead, the galaxies will pass through each other, their shapes distorted by gravity. Over time, this interaction will trigger waves of star formation as gas clouds are compressed. The spiral structures of both galaxies will likely be destroyed, eventually forming a single, larger elliptical galaxy, often nicknamed Milkomeda. Our Sun, by then about 9 billion years old, may end up in a very different orbit, possibly flung far from the galactic center. Despite its dramatic future, Andromeda also plays a key role in present-day astronomy. Because it is close enough to study in detail, yet far enough to see as a whole, Andromeda serves as a laboratory for understanding spiral galaxies in general. Astronomers use it to test models of star formation, galactic dynamics, and dark matter distribution. Space telescopes have provided stunning views of Andromeda. The Hubble Space Telescope has captured detailed images revealing individual stars, star clusters, and dust lanes across the galaxy. By surveying large sections of Andromeda, Hubble has helped astronomers map its structure and trace its history of mergers and star formation. Other observatories, sensitive to infrared, ultraviolet, and X-ray light, have revealed aspects of Andromeda invisible to the human eye. In infrared light, astronomers can see through dust to study cooler stars and the overall mass distribution. Ultraviolet observations highlight regions of recent star formation. X-ray telescopes detect the energetic environments around neutron stars, black holes, and supernova remnants. Together, these observations create a multi-wavelength portrait of Andromeda as a complex, evolving system. Andromeda also helps scientists refine the cosmic distance scale. Because it contains many different types of standard candles, objects whose intrinsic brightness is known, it serves as a critical stepping stone for measuring distances deeper into the universe. Accurate distances to Andromeda improve our understanding of how fast the universe is expanding and how galaxies are distributed across cosmic space. There's also something profoundly human about Andromeda's story. For most of history, it was just a faint blur in the sky, a curiosity without context. In the last century, it transformed into an entire island universe, comparable to our own home galaxy. It reminds us that the Milky Way is not the center of everything, but one galaxy among countless others. When you look up at Andromeda on a clear night, you are seeing a neighbor, a future collision partner, and a key to understanding the universe at large. It is both distant and intimately connected to our cosmic fate. Studying Andromeda tells us where galaxies come from, how they change, and where our own galaxy is headed. In that faint patch of light lies 1 trillion stars, untold worlds, ancient collisions, and a future merger that will reshape the local group. The Andromeda Galaxy is not just an object in the sky. It is a chapter in the story of the universe and a preview of the Milky Way's own distant future. That brings us to the end of this week's talk. If you enjoyed this episode of Relaxing Facts, then please consider subscribing or leaving a comment. I hope you have a great day, whether you're taking a moment to unwind or simply enjoying some calming listening. Thank you so much for being here. I'm Chad K, and I look forward to seeing you next time. Bye.